Okay, so first and foremost, the reason I know that this is an ellipse is because I've got two squared terms. If there were only one squared term, it would be a parabola, right? So there's two squared terms. And the coefficient of those two squared terms are different, meaning that the distance in the y direction is going to be different than the distance in the x direction, which is going to force it to look more like an oval than a circle. This would be a circle if these were both 9 or these were both 25. All right. So it's important for you to know what the shape is, because when you go to write it in standard form, the standard form of a circle is very different than the standard form of a parabola and an ellipse. So you've got to be able to identify what it is first. Okay. Obviously, it's an ellipse since that's what we did yesterday, but that's why it's an ellipse. So the standard form of an ellipse is this fraction plus this other fraction equal to 1. So I'm trying to manipulate this equation to get it to look like that. So the first thing I do is I write my x terms together and then my y terms together, but there's actually only one y term. And then anything that's not x or y, I move to the other side. So I'll have to do the opposite for that. So I'll add 16. So this could be a positive 216 rather than a negative. All right. From there, I'm going to do the complete the square method. So I get that like x minus h squared look. But to complete the square, the leading coefficient has to be 1. So I am going to divide a 9 out of each of these, so I'm only working with x squared, not 9x squared. So if I divide 9 out of this term, I'll have a 2x, and then I want to complete the square here. And normally I would divide 25 out of the next term, but there's nothing else to divide 25 out of, so I'm just going to leave that alone. All right, so what I need to come up with is what this perfect square is. So it's this number divided by 2. So 2 divided by 2 is 1. 1 squared is 1. And if I add that to this side, I have to add it to this side. But it's not just a 1. It's a 1 times 9 because of that number that came on the outside there. So you're like multiplying. You're redistributing that into that multiplier. From here, I'm going to factor. To factor, we bring down the symbol. And we divide that number by 2 squared. I can't factor this one because it's only a single term, so I'm just going to leave that as is. And 216 plus 9 is 225. All right? Now, because this is an ellipse, I want it to equal 1. So to make it equal 1, I'm going to divide this side by 225, which is going to give me the 1. But if I divide that side by 225, I have to divide everything on the other side by 225. And so the standard form of my ellipse, I'm going to do 9 divided by 225. I'm going to combine those like terms. So 9 divided by 225, just the outside part. And then I can simplify that fraction. And then 25 divided by 225. That was the coefficient on the y, and simplify that fraction. So I end up with x plus 1 squared over 25, because 9 over 225 was 25. Y squared over 9, because 25 divided by 225 is 9, equals 1. You can have like y minus 0 squared if you want to change the format of that for it to look nicer, or you can just leave it like that. So this is my standard form of my ellipse. Now my center of that ellipse is opposite of what's with x, and because nothing's with y, I'm going to have a 0. It might be helpful for you if it's asking you to find the major vertices, it might be helpful to sketch it. So thinking of it like this, like negative 1, 0 is here-ish, right? So I'm going to go in the x direction 5 units because of that 25. So I'm looking to go 5 units this way and 5 units this way. If you had actual grid, you could count them. But if I'm going 5 units to the right, I'm going negative 1 plus 5. So that's 4, 0. And if I'm going 5 units to the left, that's negative 1 minus 5. That's negative 6, 0. So those are my major vertices. And they're major because 25 is the bigger of the two radius, right? So major is the bigger radius. The bigger radius was the 25. So I'm putting those in the major spot. Now the minor would be using this radius of 9, or the square root of 9, which is 3. And that's in the y direction, so I'm going to go up and down 3. If you had actual grid, you could like count them, right? So the x value of this is staying the same. If I go up 3, I'm at positive 3, and if I go down 3 from 0, I'm at negative 3. And that's the ellipse in itself. It's a wide ellipse because the major was the x-axis. Now the final thing that we have to do is we have to find the foci, and to find the foci we need to find the c value. And so we're using this thing called the Pythagorean relation. A squared equals b squared plus c squared. A squared being 25, b squared being 9. So if we subtract this, we get a 4 as our c. And if we take the square root of each side. And so I want the foci to go in the major direction. So with the major direction, we chose x because x was bigger. So instead of going up and down, we're going to go left and right this 4. So somewhere here. If we went up and down the 4, we'd end up outside of the shape. And the focus is always inside of the shape. So if I go right 4, I'd be at 3, 0. And if I go left 4, I'd be at negative 5, 0. Obviously, that's much easier to do if you have a graph. I will give you a graph for a problem like that, okay? I'm probably on your quiz going to say, find the standard form of this, and then tell me if it's going to be a long ellipse or a wide ellipse. I wouldn't make you to find the standard form and then graph it. That would be a grading nightmare, because what if your standard form was wrong? Now your graph I'm going to have to figure out. So I would never ask you a double question like this. It would probably be this, and then based on your answer, is it long or wide? And you would say this is a wide ellipse because the x distance is bigger than the y distance. We okay with that? All right, so today we are learning our final shape. It is called a hyperbola, and it is definitely the most difficult of the 4 shapes. It has asymptotes to it. And anytime you're adding an asymptote into a shape, it's obviously going to be a little more complicated. So in your toolkit, this is on page 8. A hyperbola looks so similar to an ellipse in the formula. And a lot of what you do to graph a hyperbola is very similar to what you do to graph an ellipse. There's just some minor differences, and that's what makes it complicated. Because you got to remember what the differences are, and you have to be able to apply them to each of them. So what makes a hyperbola different from an ellipse is this minus symbol. In an ellipse, it's a plus. A hyperbola is the same formula, but there's a minus in the middle. Besides that, the formulas are identical. In a hyperbola, the important thing, what determines its shape, right? So what determines an ellipse shape is the denominators. Which denominator's bigger? That's going to determine if it's stretched wider than it is long. In a hyperbola, it's not the denominators that determine its shape. It's the positive variable. So the variable before the negative sign is going to determine the shape. So in one version of a hyperbola, the x comes first, and another version of a hyperbola, the y comes first. That's the main part. That's what determines the way it goes. So an x first parabola opens in the x direction, meaning it looks like this. This is what a hyperbola is. It's like 2 parabolas repelling. Basically, we're going to graph it the same way we graph an ellipse. But instead of making it come together, we're going to make it go out, right? It is an oval. It's just an oval going outward. So if x is first, it's going to open left and right. Whereas if y is first, it's going to be these 2 parabolas that open up and down. Right? So that's just a general sketch of what we're looking at. the width of that hyperbola is going to be determined by values. Like, it's not a quick sketch. We're going to have to plot stuff to get all of that looking the way that it's shown. All right, so what you're paying attention to here is there a plus in the middle or is there a minus? Because if there's a plus, it's an ellipse. And if there's a minus, it's a hyperbola. And then if there is a minus, what's positive, X or Y? Because that's going to determine your overall shape of the graph. Now, I have notes. I'm going to put them up there. However, if you're not someone that is ever going to look at these, like if just the visual examples is enough for you, I don't need you to write this down. I do think that some of you will go back and read this when you're on your own. So I'm going to give you a few minutes to jot it down. You just don't have to, okay? So the center's HK. And then I'm gonna put it all up, and then I'm gonna give you a few minutes. If you want to jot it down, great. If you don't want to jot it down, you don't have to. All right? And then, would you think 5 minutes is enough? That's kind of a lot. So in 5 minutes, I'll move on. I'll move this on. A lot of when we're actually doing the hyperbola is such a visual thing that you might not need the notes, but they're there. Just in time, we're starting our new stuff right now. Yes, yep, I didn't mark you absent or anything. This is optional to take notes because what I was saying is a lot of what we do is visual and you might not even need the notes, but some people like to have it. So I'm just giving everybody 5 minutes to jot them down if they want to, and if you don't want to, just hang out for 5 minutes. We're doing a hyperbola now. It's the final shape. The picture. So X is first, it opens side to side. And Y is first, it opens up and down. When you go to graph a hyperbola, the way that I'm going to do it visually, like getting all of the points, is going to be the exact same way you get the points for an ellipse. So we're going to go left, right, up, down, the radius of the denominator the same way we did with the ellipse. There are a few differences. When you connect the ellipse points, you're connecting them together. They're going in. A hyperbola, when we do the points, they're going to go out. And you have to figure out which way they go out, because sometimes they'll go out this way, and sometimes the ellipse will split this way. So it's the same points as an ellipse. The way that we connect them is different. The other thing that's different in a hyperbola from the ellipse is the formula you use to get C, and that's annoying, okay? The C formula for a hyperbola is the Pythagorean theorem, a squared plus b squared equals c squared. But for the ellipse, it's a squared equals b squared plus c squared. That's different. The number by itself for an ellipse is a squared, and the number by itself for a hyperbola is c squared. So that makes it complicated, right? So the main things you need to remember about a hyperbola is the formula for C is different. Actually, that's really the only thing that you have to remember, all right? The formula for C is different. So just kind of make that as a mental note. As you practice it, hopefully it will stick. All of this seems like a lot, but I promise you the way that we plot the points is going to be the same way we did it for the ellipse. It's just the way we connect them is going to look different. So this will be posted online if you didn't get a chance to get that. But this is a hyperbola. Here's why. In the middle of the formula is a minus instead of a plus. If that's a plus, now the graph's going to go in. The minus makes that ellipse repel rather than come together. All right? So like that's the property of what the minus does. The center is still going to be opposite of what's with X, opposite of what's with Y, which in this case, there's nothing. So my center for this first one's just 0, 0. Now, when I say shape, I just kind of, at least for the first few, just to make a mental note, I'm talking about which way it opens. So because this is an x squared hyperbola, it's going to open in the x direction, meaning it's going to open left and right. Now, if this was reversed and the y squared came first, it would open up and down. All right, so this, when I make my final graph, it's going to go opposite directions, left and right. So that's what I mean by shape. That's for an ellipse, right? For a hyperbola, what we wrote down is it's based on what's first. Oh. And x is first here. All right. Yes, if this were an ellipse, this would be a long ellipse, and y would be dominant. But what's dominant in a hyperbola is whatever comes first.
Okay. Can you just write it open horizontally?
Yeah, totally fine. This blank that says shape, I don't even think is on your quiz. I just have it in the first few notes so you can just practice what it looks like. All right. I'm actually, for right now, not even going to fill in A, B, C. So I don't want it to confuse you. Let's just plot what we know. I know the center is 0. And I know in the x direction, the radius is going to be 3, just like it would be if this is an ellipse, because the square root of 9 is 3. So in the x direction, I'm going to go 3s. That's no different than if this were an ellipse. All right. In the y direction, up and down, the radius is the square root of 16. So that's 4s. Now, if this were an ellipse, I'd go like this. Since it's a hyperbola, instead, it's going to take this part. So it's going to take this, and it's going to flip it. Don't draw that yet, because we'll draw it more accurate. I'm just taking this part and turning it the other way. All right, don't draw that quite yet. Let's just leave what we have right here. All right, so we've got these points. Those points are these things. Now, in ellipse, you have majors and minors. in hyperbolas, you have transverse and conjugate. Here's what I remember. Transverse comes first. It rhymes, right? Transverse comes first. So my transverse vertices are determined by whatever comes first. And in this case, the x came first. So the points that I plotted in the x direction are my transverse vertices. Whereas in an ellipse, my major, it has to be based on whatever's bigger. That's not the same thing. That's why we don't use the word major here, okay? So transverse comes first. So what came first is the x direction. And when I went in the x direction, I landed at these 2 points. These are my transverse vertices. And I'm just going to write them as coordinate points, all right? So a little confusing because that if this was an ellipse, those would not be what I wrote here, all right? So those 2 points are 3, 0, and negative 3, 0. Transverse comes first, which means conjugate is the other one, right? Conjugate's what comes second. It's what's left over. So I plotted 2 other points. These are the conjugate points. Does not matter what order you put them in. The way that I got those points is the same way I would get them for an ellipse. Are we okay so far? All right, now you'll notice there's this thing called asymptotes. I'm going to skip to this part for right now, and I'll go back to the foci at the end. When you are creating your asymptotes, you're going to make a box around these points, okay? So I'm going to create a box around the 4 points that I just created, right? So I'm connecting them. I'm going the full length of transverse to transverse, wide, and the full height from conjugate to conjugate up and down, and I've created this box. I'm doing it in a different color because the black box is not part of the actual graph. I'm just using it to help me get there, all right? Now, from here, I'm going to create, you know how when we make an asymptote, we do dotted lines? I'm going to create the asymptotes. The asymptotes go from diagonal through the middle. So I'm going to create the asymptotes from this box. So I'm going to do a dashed line. It's going to go from the top corner through the center to the bottom corner. And I'm going to do it the other way too. And I'm just going to extend it the whole length of the graph. And I'm going to go the other way too. What type of equations do you think the asymptotes are? That's a diagonal line. What type of equation is a diagonal line? I heard someone say it later. So the asymptotes are linear equations. All right? They're linear equations. So normally, in years past, we have kids write them as y equals mx plus b. We're actually just going to have you find the slopes of the asymptotes. You don't have to find the y-intercept. There's some extra work for that. Not for this one because it's 0. But normally there's extra work for that. We're not going to do that. We're just going to talk about the slopes of the asymptote. To find the slope of a linear equation, rise over run. So I'm going to go from the center to the corner. I'm going to do the rise over the run. So up, 1, 2, 3, 4 is the rise. Over 1, 2, 3 is the run. So the slope of this equation is 4/3 x. Now the y-intercept for this one is 0, but it's not always 0, and I'm not going to make you find it. So we're just talking slopes. If one of the slopes is 4/3, the other one's negative 4/3. They're always the same number but opposite. You could do rise over run on this side, but this line is going to have the same slope. It's just going in the negative direction. So if this is 4/3, then this is negative 4/3. You with me so far? Kind of. It's confusing. All right. Now that I have the asymptotes, I can make an accurate sketch of this graph. It's going to look like this. Okay? And it's going to get really close to the asymptote line. So from this transverse point, not from the center. The center actually isn't even part of it. All right? So from this transverse point, I'm going to get as close as I can to that asymptote line. in both directions. And I'm going to do that on this side too. All right, so what's in red there is your hyperbola. Technically, it's done. But just like the ellipse and the parabola, there's this thing called a focus that we're adding in. It's part of the definition of the hyperbola. It's not as important in graphing it. So the only thing we left out is foci, which is the 2. Remember, the thing about the focus is it's always on the inside of the shape, right? So in the ellipse, the focus was on the inside. So in this shape, the focus is going to be somewhere in here. So it's going to be inside of where it opens. So the formula to find it is different than the formula to find an ellipse. So instead of doing a squared equals, we're going to do c squared equals a squared plus b squared. C being the unknown. I don't know what C is. If I knew, then I wouldn't have to use the formula. So I'm going to leave C. It doesn't matter which you pick for A or B. So if you decide to do 3 squared plus 4 squared or 4 squared plus 3 squared, the order in that you write them makes no difference. So technically A and B really don't even matter. All right, so I'm going to write 9 plus 16 equals C squared. Because I'm doing this number plus this number, all right? So C squared equals 25, meaning that C equals 5. Now, because the graph opens this way, because the focus is inside, I need the focus to be somewhere here, which is the x direction rather than up and down. So the foci goes the same direction as the transverse did. Transverse comes first. What came first was the x. So the focus is going to go in the x direction, all right? It's going to go in the x direction 5 units. So 5 units this way and 5 units this way. These are my focus. And then I'll write them as coordinate points. So 5, 0, and negative 5, 0. A lot of it is the same, but that's not to say it's not complicated, because it is. There's a lot to remember too. You have to remember which way it opens. You have to remember that the formula for C is different. You have to remember to make this box and create these asymptotes. So there's a lot to it. All right, let's look at another one together that's not 0, 0. So it's a little more complicated. All right, so we're going to start with our center, which actually isn't even part of the hyperbola. Like when I connect it, I'm not even going through the center. But the center does base everything else. So you do need to have it. So the center is opposite of what's with x, opposite of what's with y. So my center is 6, 4. We okay so far? All right, in a hyperbola, what is important is what is first. What is first is y, which means this hyperbola is going to open in the y direction, and the y direction is up and down. So for shape, I'm going to write up, down, and I'm also going to just kind of sketch what I mean by that, just so I have a mental note of what this is going to look like at the end. And again, it really doesn't matter which you pick as A and B, so I'm not even going to fill that part out. Transverse comes first. So what comes first is the y points, right? So when I go to plot my y points, those are going to be my transverse vertices because y came first. How I plot the y points is I'm going to go in the y direction, the radius of 5, because the square root of 25 is 5. So from the center, in the y direction, I'm going to go up and down 5. And these are going to be called my transverse vertices. 1, 2, 3, 4, 5. So that first one there is at 9. And 1, 2, 3, 4, 5. The second one's at negative 1. Transverse comes first. Whatever variable comes first is the first thing that you're plotting. That goes in the transverse spot. Conjugate is the other one. All right, so in this case, the other one is the x values. So in the x direction, my radius is 2, because the square root of 4 is 2. So from here, I'm going to go 2 this way. So that's 8. 4. And I'm going to go 2 this way. 1, 2, 3, 4. 4. And if this were an ellipse, I'd connect it inward, but because it's a hyperbola, I have to connect it a different way. And before I can connect it a different way, I need to find the asymptotes to figure out how wide it's going to be. All right, so before I can connect anything, I need to create the asymptotes. And the asymptotes are going to come from this box. So you're going to go like the full width of your transverse and the full width of your conjugate. So this one was my transverse, and the x's were my conjugate. This one's my center. So now that I have this box, I can create my asymptotes. The asymptotes go through the corner of the box, through the center of the box. And they're both linear lines. And so to find a linear line, to find the slopes of them, you're doing rise over run. So from the center, I'm going up 1, 2, 3, 4, 5. The rise is 5. 1, 2, the run is 2. Those of you that are really observant will notice that rise is a y value and run is an x value. So the asymptotes are always the y radius over the x radius, 5 over 2. So y rise, so you look at the y radius, run x, you'll look at the x radius. That's where this 5 over 2 is coming from. So the opposite, negative 5x would be the other one because it's going in the opposite direction. What this does is tell me how wide or narrow the hyperbola is. So I can actually create it now. It's going up and down. So I'll go through the transverse points. And I'll get as close as I can. You can see this one's more narrow than the last one that we did. It's not as wide. And if x were first, I'd connect these ones and I'd open this way. So it just depends on what's first. All right, and then the last part is that I need a focus. Now the focus has to be some point inside this. So it's going to go in the y direction for this one because the graph went in the y direction. I just have to figure out what the c value is. So I'm going to do 25 plus 4, a squared plus b squared, or 4 plus 25. It doesn't matter the order. Ultimately, you're going to end up with the square root of 29 either way. Now, when I'm going to graph the square root of 29, I'd rather estimate it as a decimal because I'm not quite sure where that's going to fall on the graph. So I'm going to go 5.4-ish when I graph it. I'm just making an estimate. And that's going to be in the up and down direction so that it's inside of the shape. So from the center, 1, 2, 3, 4, 5.4. 1, 2, 3, 4, 5.4. Where are we at? 9.4. Where am I at here? Negative 1.4. That's the last shape. I'm going to have you guys try one. Is that fair? All right, so here is your one. It's C. I think it's the only one we didn't do. See what you can get done, and then we'll go over it. We'll go over all the steps. But just see how much of it you can get done on your own, and then we'll go over it together. They don't. You can pick whichever one you want. It really doesn't matter. I'm not going to give you those ones on the quiz. It's just to kind of set you up for your notes. Like A matters in an ellipse because it needs to be bigger. In terms of a hyperbola, it doesn't matter if it's bigger or smaller, so you can just make A as the first one. Or if you wanna keep it consistent with an ellipse and just make it the bigger one, that's fine, I like it. It doesn't matter. Yeah, there is. Hannah, I lied, by the way. Well, I didn't lie. My mom lied. The appointment is Friday, so I canceled my day tomorrow. I will be here tomorrow. So if you decide you want to come, I will be here. Yeah. We do run off the page a little for this one. I remember looking at it earlier. Yep. So I'm gonna go in the X direction, 6, which is left and right. Yeah, you'll run off the page for the focus, I think. Right?
The focus on the right you can plot.
Yeah, the focus on the one side runs off the page.
There's that.
How do I get the one first?
So did you have to find C?
No, like, I know, like.
Because it's off the page, you mean?
Yeah.
Well, you're taking the X value, right? And you're subtracting, what way are you going left? Right, so from here, if I'm going left, how many numbers, what am I going left with? Then, so I'm just gonna subtract. Or you could add, like, tick marks.
Is this supposed to be right there? 'Cause I had it.
Yeah, just there wasn't a lot of space for it. All right, so tell me if this makes sense, or if you stop me at any point, right? So let's start center. Opposite of what's with X, opposite of what's with Y. Are we okay with -3, 1? All right, I'm gonna plot that, -3, 1 puts me here, all right? And then shape, because X is first, this is gonna open left and right. I don't care if you used those words or not, right? But what that means is, it's gonna look like that.
L and R.
Totally fine. This part, this whole section is not gonna be on your quiz. It's just because these are new notes, so I'm just kinda trying to help you get there, right? Really, this is the part you need to know. Okay, so if you skip that, it's fine. But because X is first, it's opening left and right. All right, so transverse comes first, What comes first is the x direction. The radius in the x direction is the square root of 36, meaning 6. So I'm going to go 6 out. 1, 2, 3, 4, 5, 6. So this is 3, 1. 1, 2, 3, 4, 5, 6. This is, I changed my graphs different than yours because I realized it didn't fit, so I adjusted it on my paper, but it won't fit on yours. Negative, your focus won't, because negative 9, 1 is just right on the edge of your graph, right? So it's going to look a little different than yours because all of this space that I have here, you don't have. We okay with that so far? All right, and then conjugate is whatever's next, which is the y in this case. So in the y direction, I'm going to go up and down 8. 1, 2, 3, 4, 5, 6, 7, 8. That puts me at 9. So negative 3, 9. 1, 2, 3, 4, 5, 6, 7, 8. Puts me at negative 7. Are you okay with that? Questions? All right, so I want to get this sketch, but to get an accurate sketch, I'm going to need asymptotes. So I'm creating this really big box for this one. It's because my radius are very big. And again, for you, it's pretty cramped because you don't have a lot of space on that graph. Rise over run is going to give me the equations of these. 1, 2, 3, 4, 5, 6, 7, 8, which is the y radius, rises y. 1, 2, 3, 4, 5, 6 is run, which is this radius. So I have 8 over 6, which is fine. You can leave it like that, but technically, that's 4/3. I don't care if you radiate 6, right? But it does reduce. So 4/3 and negative 4/3 are my slopes. So now I can sketch this graph. For you guys, it got really squeezed in, right? Because this didn't have a lot of space on your paper, but it's really wide. This side was probably a little clear. You want it to open close to those asymptotes, which are pretty far out. Those opening left and right. All right, and then finally, I need to find the focus. For the foci, I need an x value, or sorry, I need a c value for that. So c squared is 100. So c is 10. So I'm going 10 in each direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 7, 1. And this is the part that did not work on your page. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 13. 1. And that is how we graph a hyperbola. That graph better work on your test or I'm a horrible teacher. It will work, I promise. This was just lack of preparation. I clearly did not check the answer key before I gave you your papers, right? So that's a wrap. I have extra practice, which I'm not going to make you do, but I know sometimes people ask me for extra practice. If you want it, I'm going to leave here. You don't have to come get it now. If you decide you want it tomorrow, it's just here, okay? Because I did check, and the graphs that you have in your workbook don't work. So then I just reprinted them so that you have graphs that do work. So if you want this, it's here. The answer key is on the backboard. I'm going to leave it there. It's also, I worked it out on Canvas in one of those Google Slides with like explanations so that if you're doing it at home, you have access to it, all right? Tomorrow, I'm going to show you how to complete the square for a hyperbola, which is the exact same way you complete the square for an ellipse. Really the same thing. And then we'll do quiz review tomorrow as well, and then Friday, you'll come for bonus blocks, some of you, and then Friday, we'll take the quiz. All right? If you want it, it's here. Otherwise, that's it. We're not doing the delta math, so you don't have to worry about that. If you didn't do last night's ellipse homework, we talked about it yesterday, it's just going to stay open. Do it eventually, and it'll filter in eventually. Hold on, let me just stop the, I think I have my
There's no weight points,
recording.
right?
There's not, just do it. Just do it at